Good morning, my fellow Almontians, and welcome back to another broadcast from the bunker. Today's topic is going to be going over the Continental Drift Lab you guys got the other day. Clear up any confusions, questions, anything like that. All right. Before we jump into it, let's hit the do now. You got numbers 35 to 38. Meet me there. Okay. So here we go. The first two questions deal with the celestial sphere diagram you see here. It says it's in the northern hemisphere. You'll notice that all the noon suns are shifted toward the south. Sometimes the diagrams are oriented 180 degrees the other way, but it doesn't matter. You have to go by your compass points. So now south is over here. In the northern hemisphere, the noon sun will always be at the south, and that's what's going on there. All right, so it says, which observation about the sun's apparent path at this location on June 21st, right, magical summer solstice day, what do we got, about 6 or so weeks for that, right, is best supported by the diagram. So we'll go through process of elimination here. June 21st is this nice long path. So here we go. Does the sunset occur south of west? Well, it looks like it's occurring north of west, right? Here's north, here's west. That's northwest, so A is no good. The sun appears to move across the sky at 10 degrees per hour. Well, there is no evidence of that in this diagram of rate at all. However, we know that it goes 15 degrees per hour, so B is out. Sunrise occurs north of east. Well, here's east, here's north, and there's your sunrise. That's your answer right there. Okay. Just to go over D, the sun's total daytime path is shortest on this date. Well, obviously, it would be the longest, right? You have the longest arc across the sky. So we're going to go with C on that one. Okay. 36 deals with the same diagram. It says, at noon on which date would the observer cast the longest shadow? Well, to have a long shadow, you got to have a very, very low sun. So the noon suns are on the arc here. The lowest one is this one, and of course that would be your winter solstice, December 21st. Choice A. (37). This one says the tilt of the Earth on its axis is the cause of. What does that tilt cause? Well, we know it causes seasons. With seasons comes changing length of day and night. Let's see what it offers here. It doesn't affect the length of total day, right? It'll change the amount of hours of daylight versus nighttime, but in total it'll still be 24. That's rotation. Uniform daylight hours. Well, if they were uniform, that means they would all be the same. And of course, that's not the case. If you wanted to have a 12-hour day, 12-hour night every day, well, you could either move to the equator, or you could change the Earth's tilt, right? If it had no tilt at all, you would have uniform day and night hours. Obviously, only Superman could do that. Changing length of day and night, there's your answer right there. And 365.25 days per year, that's talking about revolutionary rate, right? So that's not related at all. Got to go with C. Incidentally, the daylight of the day is still getting longer, right, until June 21st. And if you remember from classroom, we were plotting it on the board. We gain about a minute and a half, 2 minutes of light every day until June 21st. And the last one here, if the average distance from a satellite, that's an object orbiting a planet, to the Earth is decreased. So that means if the satellite got closer to the Earth, the period of revolution, well, if you get closer together, there's a greater force of gravity, which means it's pulling harder, so it'll go faster. And if you go faster, it'll decrease the amount of time it takes to get around. So therefore, if the satellite gets closer to Earth, the period of revolution would decrease because it would be going faster. Okay? That in mind, if the period of revolution decreases, then the rate must increase. Remember, time and rate are inverse. Okay, hopefully you did all right on those. Any further questions? Write them down in the comment section below. Let's jump back to the lesson here. Okay. I made a funny, I asked if you guys got the joke in the Google Classroom the other day, and if you did, I said I wanted to hear your laughter from wherever you were. I was referring to this cartoon here. Hopefully you got it, right? It's a marriage counselor with South America and Africa in the marriage counselor's office, obviously sitting far apart from each other. Look at that, they're socially distanced. But anyway, it says, well, looking back, I suppose it's been going on for quite some time, but I only noticed we were drifting apart during the last 50 million years. They're talking about continental drift and the divergence occurring there. And of course, it's a spoof on a couple having a hard time with their marriage. Anyways, the handsome-looking chap over here, that's Alfred Wegener. He is the guy who came up with the idea that the continents are moving and moving apart from each other, and he proposed lots of evidence for that. He didn't exactly know how they moved. Again, that came later through the theory of plate tectonics. But he's the guy that is credited with the idea that the continents are moving on this monster Earth. So a funny little clip for you here. Little reenactment of Alfred Wegener studying in the library, figuring out this whole continental drift scenario. Check it out.
Germany, 1911. A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa, and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaea, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory Continental Drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe. As a result, his discovery was largely ignored.
Look at that, folks. Books do come to life, huh? So a cute little reenactment there of a young Alfred Wegener putting together the theory of continental drift. Okay. In the lab that you had a cutout page. I know some of you said, how are we supposed to cut them out on the iPad? Well, if you had a printer at home, you could have certainly printed it up and cut them out, put them together, and sent me a picture of that. Or you could have copied the image and cropped it out and cut them and manipulated them digitally. It was up to you. But either way, you had to reconstruct Pangaea with these pieces. And if you did, well, hopefully you came up with something that looked like this. So your equator in the middle, North America quite a bit further down, right? The East Coast, just about on the equator there, and they're all crunched together. This is what we have today, of course, but you had to put together what it would have looked like back then. This is an image from the reference table, so you could have used that for some assistance as well. And also the pieces, if you look closely, did have some numbers to match up to help you along as well. Okay, so hopefully you did okay with that. I'm very excited to see what you sent over. All right, if you're just still polishing it up, make sure you send it over as soon as possible. Want to flip over to the lab, see if you had any problems with some of the questions here. Okay, make sure your vocabulary is done, of course. Little funny background information there, right? Who knows, in a million years, maybe the location of New York will be in the tropics. Get your beach wear now. Yeah, folks, be ready. But anyway, so yeah, make sure your vocabulary gets done. The questions down here should have been pretty easy. I'll go through a couple of them. The theory of continental drift, you know, the idea that the continents are moving about the Earth, some moving apart, some getting closer together, but constantly in motion. And every time they move, you get an earthquake. Using 8 and 9, that's the big history chart in the tables. What was the geologic age when Pangaea started breaking up? So I'm going to switch to the reference tables here. And we'll scroll down to pages 8 and 9. That's the big double map here. That's the first page. Here's the second page. And if you look, it'll tell you Pangaea begins to break up right here. And that's obviously between these two. But if you slide your finger over, it'll tell you what period that is. So I'm going to have to go up to this one here. But we said it was between 232 and 119. So just above 232. Well, what period is that? Come over to here. I'll zoom in. Okay. And just above 232, you're right around here in the Triassic period. Okay. The third one there, the compass direction. The continents of North and South America have moved since Pangaea. Well, go back to this one here. Okay. And if you take a look, it looks like North America has moved to the northwest, and South America looks like it has moved mostly to the west. Okay? Describe how the breakup of Pangaea helps prove the relative ages of the Atlantic and the Pacific Ocean. Well, remember, if the continents aren't together, then there's no water between them. But when the continents start to split, well, now you have a low point in the middle and water fills in. So, and we'll get further into this, but as the continents split, you get more and more lava coming out of the earth, and the age of the rock on the ocean floor will tell you how old the ocean is. Tomorrow's lesson will all be about seafloor spreading, and we'll get into the age of the rock and evidence of that spreading. Okay? A few more here. Number 5, what can explain the existence of coal in Antarctica? We talked about that the other day. Remember, coal made mostly from decayed plant remains. Lots and lots of plants grow in warmer climates. So we said Antarctica must have been a warmer climate at some time and moved further south, and the plants died, buried, and became coal. So the idea that, if you have a lot of coal in a place where there's no plants, well, that continent must have been in a warmer place at one time where there were lots of plants. What evidence is there that present-day continents were once single landmass of Pangaea? So there, you got to list some of the evidence that Alfred Wegener pointed out. As far as matching shorelines like puzzle pieces, the fossil connection, the coal story, all that stuff. Put it in bullet form there. Discuss why the west coast of the United States is more prone to earthquakes. Well, if you look at the plate tectonic map, and that is up just right here. Okay, the west coast of the United States, if you take a look, right here, it's on one of these crazy looking patterns. Well, these are all boundaries where the plates are moving and banging against one another. Well, the west coast is right on a boundary there, whereas us on the east coast, we're not near a boundary, thank goodness, not a major one anyway. So you're going to get more earthquakes where the plates are banging against each other, and that's for the United States on the west coast. Okay? Okay, and that was the gist on the lab there. Again, any further questions, please put them in the YouTube comment section there. Okay. But make sure it gets handed in pronto. Okay, progress reports went in today, so hopefully you had all your other labs in, all your other assignments. Try to stay on top of your work, folks. I know it gets a little overwhelming with, the new way of doing things, but remember, it's just temporary. So do your best, and we'll be back soon enough. Okay? Take care.